next up, it's going to be Khouri, Head of Developer Relations at Celestia. And he will talk about roll-up developers and if they are the future. So please give him a warm welcome. Hello. Stage is yours.
Thank you. Hey everyone, how's everybody doing this morning? Yeah? Alrighty. We're going to talk about Celestia. My talk today is going to be roll-up developers are the future. A little bit about me. I'm Yaz. I'm the head of DevRel at Celestia. I'm not going to bore you with my background and stuff, but I've been doing this for a while, for the past 6 years at Celo, Ethereum Classic, with Flashbots. So I've seen a lot of stuff, right? So yeah, let's get started. So roll-up developers are the future. What does that mean? So what does a roll-up developer even mean? It's a word that we see a lot right now, roll-ups. Are roll-ups even real? So we're going to talk about that even more. And let's get started. So a roll-up dev is the OP character in your favorite video game, whether it's Ciri from The Witcher or Kratos from God of War. For disclaimer, I've never played God of War, but Kratos pretty much looks like an OP character here. Wouldn't you agree? A roll-up dev is the hero class in your favorite fantasy genre, whether it's Gandalf with all the magic power, walking among men, fighting wars, or it's Dany who's riding dragons. Now, I know Dany shouldn't be classified as a hero because she burnt King's Landing, but, I mean, she's riding dragons, right? I mean, you got to give her credit. A roll-up dev is the ship commander in your favorite sci-fi genre. Whether it's Han Solo or Bo-Katan, they have a lot of different unique skills, whether they're leading a ship or they're like helping their crew, they're fixing things, or going into war. It's a mix of two different worlds, two different kind of qualities. That's what a roll-up dev is. A roll-up dev is a hybrid. Now, if you see the different analogy that we talked about before, a roll-up dev combines different qualities between two different classes that don't normally intersect. So let's define a roll-up dev. A roll-up dev is a hybrid of an application developer and a core developer. They are able to deploy a roll-up as easy as deploying a smart contract. Now, let's take a step back. We're diving really deep into the topic, but let's talk about the history, how do we even get here, right? So in this talk, we're going to cover how roll-ups came to be historically and where roll-up and roll-up developers are going for the future, what the future holds for roll-up development. Historically, this is how things were. So we have a concept called monolithic blockchain. So monolithic blockchains have been what we've been used to all along. A monolithic blockchain combines consensus and execution layers into one. So my experience mostly has been with monolithic blockchains, whether it's Celo, Ethereum Classic, working on Ethereum, and a bunch of random other projects that were all monolithic. So in a monolithic design, validators are verifying every transaction, and because the execution layer and the consensus layer are one layer. So that actually is highly expensive for validator to validate all kind of transactions. And then turns out in monolithic architecture, there's a separation between the core and the application developers. So if you see at the top, application devs, they're focused on the application layer. Like if you're an application dev, you're writing smart contracts, you're building things in front end and stuff, but you're not really touching anything on the consensus and execution layer. You're actually just focused on your application. While core devs, they're focused on consensus, DA, and execution. So there's a clear separation between two classes of developers here. Now, let's talk about the historic evolution of monolithic architecture. It all started out, of course, with Bitcoin. Satoshi published the white paper about Bitcoin. That's what kicked off the app chain era. In the app chain era, you got things like Bitcoin, like Monero, And then Vitalik came along later, and he published the Ethereum white paper, which kickstarted what we call the monolithic era. So what Vitalik added to the, to the whole picture is now that you have an execution environment in your blockchain. So application developers can build apps on top of that blockchain, which never really existed before. Then Cosmos, with Ethan and Jay publishing the Cosmos white paper, introduced what we call the monolithic app chain era, where every app chain has an execution environment, and they're all connected together with IBC. So that's the history of monolithic architecture. Now, naturally, this has led to a gap, and let's discover what the gap is. So monolithic scalability is linear. It's not scalable. If you want to increase your throughput, if you want to increase your block space, then linearly you have to increase the requirements of your node. So nodes get more expensive as you increase the block space to allow for more transactions. And so it's a linear relationship. It makes it more expensive to run a node, and it centralizes the entire network around a few nodes, which is not ideal. Then there's a disconnect between application and core DAOs. So we covered before that they're on two separate layers, but there exists a disconnect. So application developers can benefit from improvements to their execution environment. Let's talk about a little example. Hayden, CEO of Uniswap, would say that I wish that we had parallel execution in the EVM so that whenever there's an NFT mint, it doesn't impact users or Uniswap. Now, Hayden is an application developer. He never touched the execution environment that's covered by the core devs because he has no ownership of it. So even though he wants improvement to the EVM because it impacts his application, there's no intersect with the core devs. Core developers, on the other hand, even though they own the execution environment because it's on the bottom layer, they don't prioritize it. They prioritize the network. They prioritize consensus. For good reason. I mean, obviously, you want the blockchain in the end to produce blocks, whether the execution environment is up to standard or not. So there's a good reason for that. But because you're prioritizing the network and consensus over your execution environment, you're impacting the application developer. So there is a disconnect that we see between application and core devs. Now, I think we all agree that's a terrible reality, right? And rollups were meant to fix this in a monolithic architecture. So let's define rollups, right? A rollup is a blockchain that posts their blocks to another blockchain and inherit the consensus and data availability of that blockchain. So that's the definition in one of the Celestia blog posts, and I'm going to use that definition because I'm pretty biased here, but it's a great definition, no? So let's talk about what rollups look like in a monolithic era. So we have a thing called a smart contract rollup. This is what exists, if you see Arbitrum, Optimism, all the different layer 2s on top of Ethereum, they're what we call a smart contract rollup. So what is a smart contract rollup? A smart contract rollup relies on the settlement layer to settle transaction, and in this case, that's Ethereum. It does that by having a smart contract on Ethereum that it bridges to, right? So in this if you want to use an analogy for smart contract rollup, a smart contract rollup is a state within a country. That was a tweet by Nick White. It's a great analogy. It's a state within a country because it relies on the layer 1 for settlement. Now, there's a lot of disadvantages of smart contract rollups in a monolithic architecture. A, they don't fix scalability. What does that mean? When people tell you that smart contract rollups are great for scalability, it's not. Because in the end, let's say a smart contract rollup becomes really successful, has a big ecosystem, it doesn't fix scalability because all the users will go to that rollup, it increases transaction cost on that rollup, and you're back where you started. There's no scalability there. They are not sovereign. They're beholden to the settlement layer because if, let's say in this example, we're using Ethereum, any changes on Ethereum mainnet will impact those rollup, and they would have to adjust to the changes on Ethereum. So they're beholden to Ethereum or to the settlement layer in that case, and they're notoriously very difficult to deploy. So it turns out modular blockchain closed that gap. And let's talk about modular blockchains now. So we talked about the evolution from Bitcoin to Ethereum to Cosmos. Now, Celestia comes into the picture, where Mustafa published the Lazy Ledger white paper, and that's what introduced Celestia. Lazy Ledger is what is now Celestia. So let's talk about what's the difference between a modular blockchain and a monolithic. So in a modular blockchain, it's pretty simple. We decided to separate execution from consensus. Before they were on the same layer, now we're like, no, let's make them on a different layer. So in this model, validators, all they care about is ordering transaction. They don't verify or the transaction. So who verifies the transaction? It's the execution layer. And the execution layers in this case are rollups. So rollups actually verify the transaction while the consensus layer only orders transaction. And then you have a thing called data availability sampling. In this model, you can run a Celestia light node. I'm pretty sure you guys seen a lot about the Celestia light node on Twitter, people running it all over the world. So what are they doing? With a Celestia light node, you're doing what we call data availability sampling. You're sampling the block. You're not downloading the whole block. In other words, I'm downloading less than 1% of the block to get up to 99.99% accuracy what is included in that. Compare it to Monolithic. In Monolithic, I have to download the entire block just to be able to see what's in that block, which is not scalable. So with data availability sampling, we can get scale, because you just have to sample less than 1% of the block to get 99.99% accuracy what's included in that block. So there are different modular blockchains. So Ethereum, starting with EIP 4844, is going in that direction toward a modular architecture, which is really good to see. Then you have Celestia, with the OGs. We started the modular trend. We're providing the first modular blockchain with a DA layer. Polygon Avail has a DA layer for Polygon, and then you got EigenLayer with the EigenDA project. So this creates a new and better reality. Now, why would it? Modular scalability is actually insane, because as the number of transactions increase, because we said data availability sampling allowed you to only touch less than 1% of the block to know what's inside the block, it's actually insanely more scalable, and fees kind of stabilize over time, and they don't get more expensive. There's not a linear relationship anymore. We also have customizability in modularity. You can pick in a rollup your favorite execution environment, whether it's Cosmos SDK or Cosmosm. I know a lot of y'all here love Cosmosm, and it's actually supported on Celestia. And you also have EVM for Ethereum. If you want a sequencer, you can decide what kind of sequencer you want. You want to centralize, I don't know why you'd want to centralize, but it's the most common one right now. But you can get a decentralized sequencers. For proofs, you can have no proofs, what we call a pessimistic rollup. There's fraud proofs or ZK proofs. And the rollup types. You can have a sovereign rollup. You can have a settlement rollup. And we're going to talk about base rollup and what we call celestiums in a bit. Other benefits are what we call shared security. Now, in this model, compared to Cosmos and Celestia, so Cosmos as a monolithic ecosystem, you have what we call zones. You know, every Cosmos application is its own zone. So each one has its own consensus and DA layer inside Cosmos. That actually makes IBC kind of less secure, because if I am bridging between two different Cosmos zones, I'm relying on two different validator sets. The validator on zone 1 and the validator on zone 2. Now, naturally, maybe there's an overlap between validators between two of those zones, but they might have a different validator sets between each other. They might have different staking, like, distribution of stake. And they might have, like some might be more than others and stuff. So you're trusting two different validator sets when you're bridging between two different zones in Cosmos. In Celestia, because of modularity, we're getting rid of all these consensus and DA layers, and we have one consensus and DA layer. So the zone becomes just an execution layer with or a rollup. And when you bridge between two different rollups or zones here, you're relying on one validator set. So that's what the concept of shared security. Other benefits, so if you want to compare it between Cosmos and Ethereum, Celestia is a marriage between the rollup-centric view of Ethereum and the sovereignty benefits of Cosmos. So in Ethereum, they do have shared security. Everyone relied on Ethereum for the shared security benefits if you're layer 2, and they're easier to deploy because you just have to deploy your smart contract. Cosmos has sovereignty and scalability, but it doesn't have shared security, as we already showed, and ease of deployment. Celestia actually has all these benefits from both. Shared security is easy to deploy it, sovereignty, and scalability. So modular blockchains mark a new beginning and close the gap between application and core devs. So in modularity, if we talked about the example before for parallel execution, app developers can decide, hey, I'm just going to deploy my own rollup. And let's say if we use the parallel execution environment, me as an app dev, I can pick an EVM version or a CosmWasm version with a specific feature that I'm looking for that might not be available on Ethereum mainnet. So I can pick a feature like, hey, I want the EVM with parallel execution, and I want to deploy that as a rollup for my application with ease, with a few lines of code. From the core dev side, a lot of core devs do want to work on execution layers, but they never see it necessarily live on mainnet. So a core dev here can build an EVM version that has parallel execution and allow the application developer to use that and deploy it. So application and core dev become friends again, and that's how you create that hybrid that we're talking about, which is the rollup dev. So it turns out Cosmos came very close to that vision. With Cosmos developers in the whole Web3 ecosystem, Cosmos developers have the unique strength of having the qualities of an app developer and a core dev. You see that in different zones where the developers are both core devs when it comes to their Cosmos SDK application, and they're building the applications on top of it. However, because Cosmos developers have to worry about validators and consensus, it's a huge operational cost. If I want to deploy a Cosmos application, I don't care about validator set. I don't want to worry about validator set. I don't want to have to manage their complaints. I mean, I love validators, but you know what I mean. And worry about block rewards for them and it makes sense and stuff. I want to abstract that all away. So validators are a huge operational cost if you just want to deploy your own application in Cosmos. So the future of Cosmos is rollups. That's a fact. Cosmos is going toward a rollup-centric future where people can deploy using the Cosmos SDK. Developers can deploy rollups using the Cosmos SDK and Celestia. That's the future. This is where we're all heading. It's actually very easy today for you to deploy your favorite Cosmos SDK application as a rollup on Celestia using what we call Rollkit. Rollkit is one of the different kind of rollup SDKs that allow you to experiment with Cosmos SDK and Celestia. So for the remainder, we're going to do a little hitchhiker's guide to the future of different rollup architectures, whether it's Sovereign or Celestium, and we're also going to cover sequencer designs. So, sovereign rollups, what are they? In a sovereign rollup, all you got to do is you're posting transaction to your consensus and DA layer, and then you verify transaction. There are no smart contracts on the consensus and DA layer because all that execution happened on the sovereign rollup. So remember what we talked about smart contract rollups in the past, where they have a smart contract on a settlement layer that they rely on? Here, you don't have that. It's all on a sovereign rollup. So in the analogy given before about a smart contract rollup is a state within a country, a sovereign rollup is its own country. It's sovereign. So different sequencer selections you can do for a sovereign rollup. I'm going to talk about a bit of them. So the most common one is a centralized sequencer. right now because decentralized sequencing is kind of hard. It's still a thing that we're all trying to solve. In a centralized sequencer, you have one entity that does the ordering. We have one block producer. In a decentralized sequencer, you have multiple entities that do the ordering, so multiple people are block producers. Then we have a thing called a shared sequencer, which is even a separate blockchain that Rollup can post transaction to, and it does all the sequencing and it posts that block to the DA layer. Now, if that shared sequencer is decentralized, we also have that model of multiple block producers, multiple people are block producers. Finally, we have base rollups. So base rollups are actually very exciting. A new concept, expect to see a lot more from Celestia on base rollup. In a base rollup, we don't even care about a sequencer. We just post it directly to Celestia. Celestia does the sequencing for us. So you don't even have a sequencer anymore. With that, we see there's a lot of possibilities and expect to see a lot more about base rollup and a lot more content and different tutorials and demos about base rollup. So keep an eye out for that. Finally, we have Celestium. What we call a Celestium is it's like a smart contract rollup, except this design is different. Let's say you're Optimism or Arbitrum. Instead of just relying completely on Ethereum for settlement, you can do a different model where you post your transaction for Celestia, so you're using Celestia for data availability, but you settle on Ethereum. And on the Celestia side, validators actually do a DA attestation that gets submitted to that smart contract on Ethereum. So here you have the benefit with a Celestium of actually scaling your rollup if you're a smart contract rollup. So that's likely another design with the quantum gravity bridge. We had an incentivized testnet called the block space race, and we tested it out on the block space race and actually went live. It actually works really well. So we're very excited about this for mainnet. So tooling and text that you can use if you want to become a rollup dev, right? Rollkit is the main one right now. It's a rollup SDK that allows you to deploy Cosmos SDK applications as rollups on top of Celestia. We have Eclipse, which allows you for Solana-based rollups on top of Celestia. OPStack, I don't know if you guys seen it this week, but we released an integration with OPStack. So the integration allows you to specify what DA layer you want for your Optimism OPStack rollup. And we do have an integration with Celestia as a DA layer. In fact, on Monday morning, I think, I'm going to do a workshop on how to integrate OPStack with Celestia. So if you guys are interested in that topic, be sure to check it out. We'll deploy an OPStack on top of Celestia on Monday. You also have different developer toolings your favorite developer toolings that you can use. If you're coming from the Cosmos world, like, hey, can I use any of the Cosmos developer tooling like Cosmology? You totally can, because it's your favorite execution environment, so all the developer toolings are supported. Or if you're coming from the EVM world and you're wondering, hey, for my rollup, can I use Foundry? Absolutely. You can use Foundry, MetaMask, Hardhat, all your favorite developer toolings. So the future of Cosmos is one of abundance, thanks to the speed of deploying a rollup as easily as deploying a smart contract. That's the future that we hold. And we covered Celestia light nodes. So Celestia light nodes help make rollup scalable because of data availability sampling. So it allows you to sample less than 1% of the block to get 99.99% accuracy about what is included in that block. Examples of people running light nodes. If you guys haven't run a light node, it's really easy. If you guys want questions about it, I'm happy to help you get started. But we had a whole, for fun, deploying it on Nintendo DS, on a Nintendo Switch. So I'm not a Nintendo person. I'm more like a Sony person, but yeah. One of our community members deployed a light node on a Kindle. And we thought that was impossible, but he got it working. There's a Kindle that is running a light node. One of her, Natalie actually had it running at a beach party on a phone. So the third photo is actually on a phone. One of her core devs actually started running it on a Tesla. We have it running in Greece on a Raspberry Pi. On the last photo, I was running it from a Riyadh in Morocco because I felt kind of fancy, right? So here's the reality. With Celestia, Cosmos developers can build whatever. When you can build whatever, what does that even mean? People come up to me and ask me all the time, what can you build with Celestia? And I always tell them, you can build whatever you want. It's like infinite kind of landscape. Modularity allows you to mix and match and play around with different kind of tools for your favorite kind of application. Build whatever. Remember that. That's what you can do with Celestia. And with that, thank you so much. If you guys want to check out Rollkit, you can scan the QR code. If you want to hit me up on Telegram and Twitter, that's my information, on email. Although I might not check my email often, so forgive me. So probably Telegram or Twitter is better. Anyway, thank you so much.